Hello my dear children, as you know our chapter is going on in class 12th solution. Now we are on the last second last topic of this chapter is colligative properties. After Raoult's law, after covering ideal and non-ideal solution, my topic is colligative properties. Write down what are colligative properties which depend upon the N. N is the number of moles of solute. Those properties which depend upon the number of moles of solute, they are called colligative properties. Colligative properties never depend upon the nature of solute. Remember this, they never depend upon the nature of solute. They only depend upon the number of moles of solute. Write down. Depend directly. Now there are 4 colligative properties. The first is lowering in vapor pressure. Second is elevation in boiling point. Third is depression in freezing point. And the fourth is osmotic pressure. There are the 4 colligative properties. One by one I will take. Within 2 days we will complete all the properties. 2 lectures sufficient for these. Colligative properties is a topic. Write down first is lowering in vapor pressure. This is a property that we have already covered in the Raoult's law when we have taken the derivation solute is non-volatile. Write down lowering in vapor pressure. Derivation to prove that lowering in vapor pressure is a colligative property. Write down. Now, I think you must remember the 2 beakers in which in one beaker we have taken solvent only. This is my pure solvent A. No solute is present in it. It is a volatile solvent. Lot of vapors are coming out. System is closed. And this side when I add solute, this is my second beaker. Now I want to prepare a solution, or it is a solvent A plus solute B. Now remember this solute is non-volatile. The moment non-volatile solute is added, it occupies the surface sum of, and this is a solute. When it occupies the surface, what it will do? It will decreases the surface area, and now the solvent molecule get a less chance to escape into vapor. Now you know this is a decrease in the vapor pressure of the solution than solvent. Vapor pressure of the solvent is more, but the vapor pressure of solution is less. Write down vapor pressure. Less the vapors, less the pressure. So this is a derivation based upon these 2 beakers. We have already done. Again I am repeating. Write down the derivation. You know PS is equal to PA plus PB. PS is equal to PA plus PB. PA is equal to 0 as solute is non-volatile. So PS is equal to PB only. Put Raoult's law. PV is P naught B XB. Simplify it. You know XB is equal to 1 minus XA. And after that you write, open the bracket, simplify it. It becomes PS is equal to P naught B minus P naught B XA. Again simplify. It is now PS P naught B XA is equal to P naught B minus PS. Come to this side and this side. Now it is XA is equal to P naught B minus PS by P naught B. What is P naught B minus PS? It is your lowering in vapor pressure. Remember this. It is your delta P. Write down delta P is the lowering in vapor pressure. And delta P upon P naught B is a relative lowering in vapor pressure. It's a relative lowering in vapor pressure. Delta P is the lowering in vapor pressure and delta P by P naught B is a relative lowering in vapor pressure. So what this derivation suggests, XA is equal to delta P by P naught B. Delta P proportional to XA. XA is your solute moles. So hence it is proved lowering in vapor pressure is a colligative property. Write down that proved lowering in vapor pressure is a colligative property because it depends upon the number of moles of solute. Delta P proportional to XA. Proved it is a colligative property. Those properties which depend upon the number of moles of solute. Write down application. Application of lowering in vapor pressure. And remember, every colligative property is used to determine capital M. Capital M is the molecular weight of non-volatile solute. So let us calculate how it is useful now. Write down again. Derivation. Delta P by P naught B is equal to XA, or P naught B minus PS by P naught B is equal to Na divided by Na plus Nb. Next step is when the solution is dilute, then denominator carrying only moles of solvent. Na plus Nb is equal to Nb only. When the solution is dilute, you have then moles of solvent only. Simplify P naught B minus PS by P naught B is equal to Na by Nb. Next, up to molecular, now you carry on further. P naught B minus PS by P naught B is equal to small ma by capital Ma, small mb by capital MB. Or you may write P naught B minus PS by P naught B is equal to small ma by capital Ma, small mb by capital MB. Round it off. Now let us start with the numericals. So this property is used to calculate capital Ma. Write down. So every colligative property has a common use. Two things are common. One, every colligative property dependent upon the number of moles of solute. And the second, every colligative property is used to determine the capital Ma. Write down numericals of this property, that is delta P. Numericals. Now the first numerical is, take down the first numerical, open the NCERT exercise. The first numerical is, this is your numerical number 17. 16 is of ideal solution. I'm taking numerical number 17. Write down the numericals of delta P. The vapor pressure of water is 12.3 kilopascal. The vapor pressure of water is 12.3 kilopascal. Temperature is given at 290, at 300 Kelvin. No need to write temperature. Question is calculate the vapor pressure of 1 molar solution. Calculate molar. Calculate the vapor pressure of 1 molar solution. Vapor pressure of water is given at 300 Kelvin and they're asking calculate the vapor pressure of 1 molar solution. So what you will do, you will apply the formula P naught B minus PS by P naught B is equal to XA, or you may put Na because it is a 1 molal. What does it mean by 1 molal? 1 molal means 1 mole of solute present in 1000 gram of solvent. 1000 gram of solvent. So if it is your, it's XA here. So I converted XA is Na by Nb. I go further, small m by capital M. No need to take this. Now you may write simple Na by Nb. You write simple formula you apply because it's 1 molal. So you write Na by Nb. Now your Na is 1 molal, 1 mole. You put 1 mole. It's 1 mole. And your Nb is small m by capital M. Because it is 1000 gram, so your small m is 1000 and capital M is water is 18. That is, it's a 55.55. So you apply the formula, you put the value. Now P naught B is a vapor pressure of pure solvent, not for pure. It's 12.3 minus PS is your target. You want to calculate the solution vapor pressure by again 12.3 is equal to 1 mole by 55.55, and PS is the answer. So this is one of the numerical of this chapter. That is topic is your lowering in vapor pressure. On the same page, I'm taking 15th numerical now. Now it's a 2% solution. Write down 15th numerical. 15th. In the 15th numerical, the solution is 2%. A 2% solution has a vapor pressure 1.004 bar. Write down 2% solution. Solution has a vapor pressure 1.003 bar. Next is, the question is calculate the 15th numerical it is. It is specially given at the normal boiling point of solvent. This vapor pressure is given at the normal boiling point of solvent, specially given. Now students, what you will do, now question is calculate the molecular mass of solute, capital M you want to calculate. You apply the formula. Formula is P naught B minus PS by P naught B. Another side, because the solution is of mass 2%, so right hand side you apply small ma by capital Ma, small mb by capital MB. It is 1.013 bar. Now question is from where it has come. Because it is a vapor pressure of pure solvent. Write down. You may write here 1 atmosphere at the normal boiling point, or you may write here 760 mm, or you may write here 1.013 bar. These are the constants. At the boiling point, the vapor pressure is this: 1 atmosphere, 760 mm, 1.013 bar. Because your PS is given bar, it is 1.003 bar. So that's the reason I selected the unit bar. It's a bar, so I've not selected this. So write down 1.013 minus 1.003, again it is 1.013 is equal to, small ma is 2 gram, 2% it is, 2 gram solute. Calculate the capital M. It is your 98 gram, because 2% means you have 2 gram solute, 100 gram solution, and rest is your solvent, and your solvent is water. So write here 18. Aqueous solution it is, 2% aqueous solution. So this is all about, you calculate your capital MA. So on the same page there is given numericals number. Now you attempt at your home, your numerical number 18, and in text and examples are there. You can do it. You can attempt the numerical number 17 and 34. Write down 34 numerical and 17. And now the next two properties we will take tomorrow, because these two properties are of same type. So that I will take collectively. Write down my second colligative property is elevation and boiling point. These two properties I will take together. And the third is depression and freezing point. So in my next lecture, I will take these two properties, elevation and boiling point and depression and freezing point. So this is my request to all of you. You are in class, that is 12th. This is your career year class. Kindly go through my lecture regularly. Whatever the numericals I am giving, attempt those numericals. Any problem coming, you can share with me at any time. Give me the message, I will solve your query. Now, your topic is your delta P. Now, you calculate the numericals of delta P today. There are examples given, there are 1 or 2 in-text given and 2 exercises left. You can attempt yourself. Any problem come, you can share with me. Thank you.